Today's my topic of discussion is Fermi level. What is Fermi level? It is a highest fill-up energy level at T is equal to 0 Kelvin, and the energy corresponding to the level is called Fermi energy, and Fermi energy is represented by EF. All we are familiar with the Fermi-Dirac distribution function. If E equal to 1 by 1 plus exponential E minus F by kt, where the distribution function Fe is defined as the probability that a quantum state with energy E is occupied. And here Ef is the Fermi energy, and K is the Boltzmann constant, and T is the absolute temperature. Let's see. At T equal to 0 Kelvin, and when E less than equal to Ef, that means this is the Fermi energy level, and E less than Ef means the energy states are below the Fermi level. And for this condition, we get from this distribution function Fe equal to, when E less than Ef means upper term is negative and T is equal to 0, so minus infinity, and exponential minus infinity means 0, so 1 plus 0 equal to 1, and 1 by 1, so this is equal to 1. Thus, probability of occupation for T is equal to 0 Kelvin when E less than equal to Ef. Thus, you can say at T is equal to 0 Kelvin, E less than Ef, all the energy state below the Fermi energy level is filled up. Now, for E greater than equal to Ef, when E greater than equal to Ef, so upper term is positive, and positive by 0, so exponentially plus infinity, and exponential plus infinity means infinity, so 1 plus infinity, infinity, so 1 by infinity is equal to 0. So, if E equal to 0 for E greater than Ef. Thus, Fermi level is defined as the energy level at T is equal to 0 Kelvin. All the energy levels below the Fermi level are filled up, and above which the all states are empty. At T is equal to 0 Kelvin, thus Fermi level is defined as the energy level below which all the energy states are filled up and all the energy states are empty. But T greater than 0 Kelvin, we can't say that the Fermi level is the topmost fill up energy level, because T greater than 0 Kelvin, number of electrons may be excited from field energy state to the higher state. So, number of energy states below the Fermi level would be occupied, and number of energy states above the Fermi level would be occupied. So, greater than T is equal to 0 Kelvin, number of energy states below Ef would be unoccupied, and number of states above Ef would be occupied. So, we cannot define T greater than 0 Kelvin, the Fermi energy level is the topmost occupied energy level. But we can say from this expression at T greater than 0 Kelvin, when E equal to Ef, and E is equal to Fermi energy. When E equal to EF, then this term will be 0, but T greater than 0, so exponentially 0 means 1. So 1 by 1 plus 1 means probability of occupation become half. Thus, we can define the probability, Fermi level is energy level at T greater than 0, where the probability of occupation is half. Now, I will talk about the position of the Fermi level for semiconductor. Let's see the energy diagram for semiconductors. And this is energy band diagram for intrinsic semiconductor. And for intrinsic semiconductor, we know the concentration of electrons in the conduction band is equal to the concentration of the holes in valence band. So the Fermi level lies at the middle of the band gap, obviously at T is equal to 0 Kelvin. But T greater than 0 Kelvin, the Fermi energy level shifted upward slightly because of lower effective mass of electron than the hole. Now let's see for n-type semiconductor. Since for n-type semiconductor, an extra donor impurity level is developed just below the conduction band, and where number of electrons present, and due to the presence of electrons in the donor level, the Fermi level shifted upward. Let's see for p-type semiconductor, and this is the energy diagram for p-type semiconductor. This is conduction band and this is the valence band. For p-type semiconductor, an extra energy level is developed just above the valence band and is called acceptor level. And in acceptor level, number of deficiency states are there, and they are called holes. And due to the presence of holes, due to the adding of p-type impurity, number of vacancy states are developed in the valence band or near the valence band. So the Fermi energy level for p-type semiconductor shifted downward. But for extrinsic semiconductors, the position of the Fermi level depends on the doping concentration. When for n-type semiconductor, doping concentration increases, the Fermi level move closer to the conduction band, and for very high doping concentration, Fermi level goes into the conduction band. And for p-type semiconductor also, for high doping concentration, Fermi level goes into the valence band. And these type of semiconductors are called degenerate semiconductor, and these semiconductors are used for the construction of tunnel diameter. Thank you.